Bismillahirrahmanirrahim. In today's lecture, I am discussing about the change of basis matrix. So this lecture is just to help you, as we already discussed these things in the interactive session. So I am uploading these notes together with the explanation again, just to facilitate you. So suppose we have vector space R2 and we have two bases of R2. One is the natural basis S, whom we can say E1 and E2 vectors, 1 0 and 0 1, and the other basis is T 1 minus 1 and 2 1. So suppose we have two bases and we want to know that how can I translate the vectors who are written in the form of basis S into the vectors who are written in the form of basis T. So here I am naming these two vectors, basis vectors of T, as B1 and B2, and the natural basis vectors are E1 and E2. So if I draw these vectors here, then E1 and E2 are along the x-axis and y-axis. And the new basis vectors B1 and B2 are here. This vector is 1 minus 1 and the vector B2 is 2 1. Now suppose if I am given a vector 1 1 and I want to know that how can I reach this vector 1 1. So in fact, any vector which we write in our simple or standard basis, for example 3 5 is a vector which I have to write in our simple or standard basis, then what we do, we move 3 times along the vector E1 and 5 times along the vector E2. Or you may say we travel 3 units along the x-axis and 5 units along the y-axis to draw this vector 3 5. Now similar work we have to do if we draw a vector that is written in the form of basis T. For example, if x is a vector that is given in the form of the basis vector of T. So what we have to do, in fact we have to do that we have to move 1 unit along B1 and 1 unit along B2. So if I walk 1 unit along B1, that is we reach on the tip of B1, and then I move along B2 and 1 unit along B2, then I reach here. And if we draw this vector, then this vector, the position vector of this is representing the vector 3 0. So if I solve this here, I put simply the value of B1 and B2, then I obtain the vector 3 0 here. So 3 0, basically the vector is given in the basis of S. So the vector 3 0 in the natural basis is represented as the vector 1 1 in the basis T. So both of the bases are generating R2, but in their own language. So the language of T says 1 1 and the language of S says 3 0. So the question is, how do we convert these languages or translating into one another language? For this, we create a basis matrix. By using that matrix, I multiply any vector with that matrix to change the basis or change the language or interpretation of the basis. So for conversion of this basis vector, what we have to do? First of all, I am writing a matrix that converting T bases into S bases. So by writing this matrix, I mean that I write all the vectors in the basis T in the language of S. So what I have to do, I have to write B1 in the language of S and I have to write B2 in the language of S. So if we clearly see here the vectors 1, -1 and 2, 1. So initially these basis vector which I draw here are already given in the language of natural basis, because we have to start from somewhere. So any other basis other than the natural basis are already written in the form of natural basis, but they are initiating their own space then. So the existence of them are there due to the natural basis. So in fact B1 and B2 are already in the natural basis. So I simply write in B1 in the basis S is given as 1 -1, that are the components of B1, and similarly B2 is 2 1. So 1 -1 and 2 1, and I write these two vectors in the columns and I get the matrix that transform T into the natural basis. So in fact the conversion of any other basis into the natural basis is very simple. What we have to do, we just write a matrix. In that matrix we write all those vectors in the column. So we get the matrix of transformation that convert any other basis into the natural basis. So if we see here, we apply this matrix on our vector 1 1, which we converted here also. Then I again get 3 0, and this 3 0 is its component in the S basis, or in the language of S basis. So this is the change of basis matrix from T to S. So I end this video here, and the next part of this video is in the part 2 of the video. So we will continue this lecture in the second part of the video. Thank you very much.